Alright, right and left hand limits. Let's talk about this again. We've already talked about what a limit is. Again, it's just the intended height of a function. And we talked about how there's three ways to solve limits: numerical, which is used as a table; graphical, which obviously uses a graph; and analytical, which uses algebra or calculus. For a right and left hand limits, it's important for you to understand what they're asking about. So let's go to the next page so you can kind of see some examples of that. Alright, so what you see here is we have this notation here that says as x approaches 2, and then it says positive. And this notation, this left-hand limit notation, looks exactly the same. It says as x approaches 2, and then from the negative. These just are telling us a direction that we're approaching from. The positive direction is to the right, and the negative direction is to the left. So that's all they're really asking. When they say, what is the limit from as x approaches 2 from the right, all we're saying is if down here, if this was 2, what is the height that we're approaching from the right? So this is the limit as x approaches 2 from the right. And then the other one is just asking, hey, well, what is the limit as x approaches 2 from the left? So this is the limit as x approaches 2 from the left. That's all they're really saying. In this situation, they're saying that they both have a height of 4. So they meet, that means that they're meeting at the same spot. Okay, because we might have situations where the limit, maybe the graph looks something like this, and there's a hole, and then it starts up here and it goes. In that situation, the limit from the right is obviously not equal to the limit from the left. They don't meet at the same height, and so these two limits would not be equal to each other. The right hand and the left hand are not the same. So if the heights from the right and left are the same, then the general limit exists. So in this situation it exists. In this situation, the limit, or we would more specifically the general limit, does not exist. And so we're going to play with that a little bit more. Let's go on to the next page. Okay, here we see it says find the left and right hand limits and state if the general limit exists at x equals 4. So let's do that. Let's find the left hand limit first. Well, the limit as x approaches 4 from the left, which is from the negative side, and this thing is called g of x, so we'll just say of g of x. What does that equal? Well, we can look at this thing and we could follow it. What is the height approaching? Well, it looks like it's approaching 1, so I'm just going to say 1. Now, what is the limit as x approaches 4 from the positive side, or from the right? And this is also of g of x. Well, we can follow it from the right side and we can see that it approaches 2. So we see that it equals 2. And now they're asked to state if the general limit exists at x equals 4. Well, we could see that from the left it's 1 and from the right it's 2. Since they are not equal, we could say that the limit, or the general limit, does not exist. Because in order for it to exist, these two things have to be exactly the same. That's kind of all there is to it. Alright, let's take a look at the next page. Okay, in this example it just says show that the limit does not exist. So before we can do that, let's get a graph of what this thing looks like. And before we get a graph, what I would like for us to do is kind of make a little table like we did before, because that's going to be the easiest way to graph this thing. So here's our x, and here's our y, and we'll say that our y equals the absolute value of x over x. Now we could have also called this f of x or g of x or something, but it doesn't really matter, just as long as we are consistent. So let's pick a few points. If there's no other information, I like to center it around 0, so I'm just going to go -3, -2, -1, 0, 1, 2, 3. That should be plenty of information to get a good idea of what this graph looks like. So if I plugged in a -3, took the absolute value, that'd be a +3 on top, divided by -3. Well, 3 divided by 3 is 1, but since it's 3 divided by -3, it's going to be -1. And the next one is going to be -2, which inside the absolute value brackets makes it +2 divided by -2. Also -1. We can see a pattern here. -1, absolute value is 1 divided by -1. -1. Now at 0, we cannot divide by 0. 0 divided by 0 is not 0. It does not exist. Then we get 1 divided by 1, which is 1, 2 divided by 2, which is 1, and 3 divided by 3, which is 1. So we got an idea of what this thing looks like. If we were to go back to -3, we know that all these points are on a straight line, and then if we go to +3, we know that all these points are on a straight line. So it looks something like this. But we do know that at 0, it does not exist. So we put an open circle there just to denote that it does not exist. So, what is the limit as we approach 0 from the right? Well, just follow it along. Looks like it's approaching 0. It's actually +1. Remember, limits don't care about holes. They just care about the intended height, or the value you're approaching. Not the value that it actually equals, but the value that it's approaching. So as we approach 0 from the right, we notice that we're approaching +1 because it's +1 the whole time. So this is +1. As we approach 0 from the left, we're approaching -1. So the limit as x approaches 0 from the left is -1. And now, what is the general limit? That means, do these two limits from both sides, do they equal each other? Well, they don't, right? One's 1, one's positive, one's -1. They don't equal each other. So this, we would say, does not exist. There is not a general limit here, because in order for the limit to exist, the general limit to exist, it has to be the same from the right and the left. Alright, that's it for this video. See you guys on the next one.